Hi, so in this video we are going to look at one of the introductory topics to biology, and we're going to be talking about levels of organization. So levels of organization, right? So what I'd like you to do is take notes with me. So anything I'm writing, can you also be writing? Because I think when you are taking your own notes, it kind of creates, if you like, nervous pathways, and they are helpful to remembering information. So I do advocate taking your own notes. So why am I talking about this particular topic? Well, because it doesn't explicitly come under any of the units we teach you. However, I feel it sort of creates one of the fundamental bits of knowledge which you do need to be aware of in order to make sense of, some of the information we're giving you at level 3 in this course. So what levels of organization essentially refer to is taking an object and looking at it more and more closely, so basically kind of zooming into it to see what this object is made out of. Equally, you can zoom out of objects or things to see what the bigger picture is. So that would also be part of levels of organization. Now, the biggest unit within levels of organization we're interested in is human body. So this is our first level of organization, so human body. Now, of course, you can take several humans and start looking at the way they interact, they live together, but that would be a subject for, let's say, psychology or sociology. Or you can keep on zooming out and look at planets and cosmos, and that would be topic for something like cosmology. But because we are looking at physiology and physiology of human body, this is kind of where our starting point is. So if I now take this human body and start looking on what it's made out of, so the question is, well, what is the next level of organization? And you could kind of pause this video at this point and have a kind of scratch your head and have a think about it and try to come up with an answer. What is human body made out of? And we need to kind of look at it in a very systematic way, right? So what is the next level down? And I'm hoping that some of you might be able to come up with correct answer, and the answer will be systems of organs. Okay, so some of you might have thought about organs being the next level, but actually, if I did that, I would have missed out that whole level of organization. So we will have a separate level, separate lesson on systems of organs. But for now, I'm going to just, let's say, name one of them, just an example. Let's pick, for example, digestive system. Right, and obviously there are quite a few other systems of organs. And if I take that digestive system as an example, then I can swiftly move on and move to the next level of organization, which would be organs. Right, so if I take a system of organs, start looking at it in more detail, I will see that it's made out of individual organs. So let's take digestive system as our example. So can you again pause the video and write down as many organs within digestive system as you can. Now, try to do it without looking at any secondary resources or websites. Just, write down a little list, let's say between 2 to 5 organs, anything you can name within digestive system. So I'm hoping you'll be able to name a few. So maybe some of you thought about stomach, or let's say liver. So liver belongs to your digestive system. Or maybe you thought of, let's say, small or large intestine. So these are some of the example. some of the examples. Obviously, there are a few more organs. Maybe I haven't named there, and maybe you did. So well done. So the next question is, well, if I take one of these organs, let's say stomach, and start looking at that in more detail, what is stomach made out of in turn? You know, if I take it in my hands and start sort of really opening it out and seeing what is there, what will I be able to see? And the answer to that question will be my next level of organization. Again, I'm hopeful that some of you might be able to recognize this term. And actually, your organs are made out of something called tissues. So tissue or tissues. And you might think that because human body is really complex, there must be lots and lots of different types of tissue. Well, there are lots of different subtypes of tissue, but actually there are only 4 main types, so just 4. And I think it'll be really useful to remember the names of these types of tissue. So one of the types of tissue, so let me write it down. So there are 4 main types. Okay, just 4 main types. So again, some of you might be able to name 1 or 2. I'm really hopeful here. Well, let's see. So the first type is connective tissue. Okay, so well, where would you find connective tissue? So that could be, for example, something like your ligament, right, or something like your tendon. So that's kind of easy to understand, because obviously these are things which are connecting different organs together, so hence connective tissue. But also, maybe slightly confusingly, but blood is also a type of connective tissue. Well, kind of, you can think about blood as connecting different parts of your body as a transport liquid. So in that sense, it's also a connective tissue. So these are just some of the examples. So the next type of connective tissue is nervous tissue. So this is quite easy to understand. So anything to do with nerves, so for example, nerves or your brain, that would constitute, something, organs or types of your sections of your body made out of this nervous type of tissue. So the next type is epithelial. Now this is the one you maybe not heard of. So this is essentially coverings of organs, both internally and externally, right? So this is coverings, of organs. If I misspell something, by the way, don't be too angry, just, change it, because I'm scribbling away and sometimes don't notice things. So coverings of internal and external organs. Okay, so, well, quite simply, a really good example would be just your skin, right? So, for example, skin. And then the final type of tissue is your muscular tissue. Okay? Now, the muscular tissue I'm going to spend a little bit more time on, because there are 3 subtypes. So here you go. I'm going to kind of spread those out. So it's going to be 3 subtypes of muscular tissue, and it's really important to be aware of these subtypes and be able to recognize them, because these are the words which are going to come up in different units. So the first subtype of muscular tissue is smooth muscle. Okay, and this is a type of muscle which you cannot control consciously. So this is outside your conscious control, is your smooth muscle. Now, the next type is skeletal. Skeletal, some different people pronounce it differently. So just stick with the pronunciation you're comfortable with, some muscle. So skeletal muscle. So skeletal muscle is within your conscious control. Okay, so before I move on to the third one, let's talk about these ones. So let's say I stood up and I walked from one end of the room to a different end of the room. Or, for example, just take me writing something on a piece of paper. Which type of muscle out of these 2 do you think you would be using? Okay, so from everything I said, which out of these 2 types would fall, which type would it be, right? And I'm hopeful you would be able to correctly pick skeletal muscle, right? Because you choose to stand up and go to a different side of the room. You choose to write something down, even though you sort of, you obviously don't think about how to write L or A, in great amount of detail, but it's still your choice. So all of these muscles are under your conscious control. So let's think about types of kind of examples of muscles outside your conscious control. Well, my first question would be, what do you think is the largest mass of smooth muscle in the female body? Okay, so that's one of the questions for you. And I'm not going to answer that question right now. I'm going to kind of maybe ask you next time I see you face to face. And my next question is, what do you think is the largest mass of smooth muscle in a male body? Okay, so these are two different organs, right? A lot of people start sort of giggling at this point. So let's see what your answer would be, okay? So this is something I'm going to check when I see you. So then the third type is called cardiac muscle. Cardiac muscle. Now, I wonder if some of you would be able to suggest where you find cardiac muscle, because really the key is that word cardiac. And I'm hoping that some of you are going to be aware that cardiac is something to do with your heart. Right, so if you have cardiovascular disease, it's something to do with your blood vessels or your heart. So in this case, it's specifically found in your heart. Now, why would your body need specialized muscle just for your heart? Well, I want you to do a very simple little experiment, which you can do right now. So let's think about how many times your heart contracts every minute. And it's something you can kind of look up. But again, depending on the person, you're talking maybe between 60, 70, 80 beats per minute if you're resting, right? Obviously, if you're running, it'll be a lot higher. It could be 100, 120 or something like that, depending on your level of fitness and all sorts of other things, age, etc., etc. So what I'd like you to do is very simply take your hand, right, put your pen down, and then kind of pump your fist for me very, very quickly 60 times. Let me go easy on you. So I want you to actually do it and keep counting and keep doing it. And you might have to pause the video to do it, but keep going and keep going until you do it 60 times, okay? 60 times, keep going. So once you've come back to the video and you've done your 60 fist pumps, you can sort of tell me how it feels, and I hope you appreciate that you probably feel pretty tired by now. Now, this is something your heart does, every day for 60 minutes of every hour, for 24 hours every day, for 365 days a year, for 70, 80, 90 years, or maybe even 100 if you're lucky, and you're going to get your birthday card from the Queen, right? So that's the kind of work which your cardiac muscle has to do. So you can see why something like smooth muscle and something like skeletal muscle, it really wouldn't work. So the nature had to come up with this very special type of muscle just to be able to do this amount of work and do it reliably, okay? So this is tissues, right? So you remember where we started? We were talking about levels of organization, and for a minute we got to the types of tissue. So we discussed that the stomach would have several types of tissue. So you would find connective tissue there, you would find some nervous tissue there. You're certainly going to find some epithelial because you have covering of the stomach, on the outside, of the inside. So that's going to be epithelial, and certainly going to find some muscular tissue in there as well, because that's what's going to be able to get your stomach churning, right? And by the way, right, very, very quick question, which type of muscle tissue would you find in your stomach, right? So have a think about it. Is it cardiac? Is it skeletal, something you can think about and control? Or is it a smooth muscle which you cannot control consciously? Okay, so make your choice here. All right, so then the next question obviously is going to be, well, what is going to be the level of organization number 5, right? So what is what is this type, all these different types of tissue made out of in turn. So if I take, let's say, muscular tissue in your stomach and really zoom in, and at this point I'll have to start using microscope, by the way. I can just about see tissue with my naked eye, right, as a sort of little sliver of thing, but I certainly won't be able to see the next level of organization with a naked eye. I would have to move on to using microscope. So I'm again hoping that some of you would be able to name this next type of level of organization, and that would be cell, right, or cells, obviously, because you have numerous cells making up a particular type of tissue. So, well, what about cell? So, again, you will look at the cell in a lot more detail in cell biology units. So, cell biology unit, which you're going to be studying. But for now, I'm just going to have very, very brief overview. So, if I draw a quick cell, so it's got this sort of round blob in the middle, and it also has got some bits and pieces, some of them different shapes, sort of kind of ovals and little dots and little circles, right? So I'm wondering if you would be able to name three components of a cell. So what is the outer shell called? What about that round blob in the middle of the cell? What do we call that? And the next question is, well, what do we call all these different inclusions? Like as a kind of generalized term. So what would I put as names for these three lots of label lines? Okay, again, I'm going to ask you to pause the video, do the labels, maybe in pencil, so you can rub it off if you're worried about getting it wrong. But I'd like you to have a go at writing those labels down for me. So again, I'm hoping that some of you will be able to name these components. So the first one, the outer shell, is going to be cell membrane. Then the blob in the middle is going to be nucleus. And by the way, this contains a long molecule called DNA, which you might have heard about, right? And then the last term, which I'm looking for, is names of kind of collective term for all these other bits and pieces which are suspended in the cell, and they're called organelles. Okay. Now, some of the examples of organelles, so again, for some of you might be completely alien words, but maybe some of you will know. So, for example, so it could be something like mitochondria, or maybe things like ribosomes, or maybe things like lysosomes. So if you've never heard of this before, don't worry too much. You're going to learn about it in this cell biology unit. By the way, I'd like to add one more label. Let me squeeze it here. If you haven't got space in your note, just put it on one side. And this label is going to point at the kind of the jelly-like substance in which all these organelles are suspended. So again, some of you might be able to name this term, but if not, I'm going to name it for you. So it's called cytoplasm, right? So this gives you sort of quick overview of what you would find in a typical cell in the human body. Okay, so then the next question is, okay, so we go to my level of organization number 5. So we started with human body, and we're sort of zooming in and in and in and in, go to the cell. Well, what about the cell itself? So if I, let's say, take cell membrane, and I'm going to keep on zooming into this cell membrane, what is that going to be made out of? You know, what is my level of organization number 6? Right? And this is where a lot of people get a little bit lost and a little bit stumped. Now, sometimes people start telling me, is it something like proteins? Or maybe lipids? And I kind of say, well, yeah, you're kind of right. You know, you do find things called proteins and lipids and DNA in your cell, but I'm looking for a general term for all these things. So what kind of things are proteins and DNA and lipids and, let's say, water, etc.? What is the term given to all these things? And I think that's where sort of a lot of people start scratching their heads. And if you do know the answer, then amazing, absolutely well done, because the answer is actually molecules. Okay, so the collective term for all these things is just a molecule, or molecules, more molecules. Okay. Now I'm gonna leave a bit of space so you do the same, because I'm gonna actually start on looking at the next level of organization, and then I'm gonna come back to molecules. So my next question, I'll have to start on the next sheet here. So let me just move it into place. So my next question is, well, what are molecules made out of, right? Which is my level of organization number 7. And again, here we get sometimes hit a bit of a brick wall, right? So what are molecules made out of? And the answer here is atoms, right? So atom or atoms. Again, probably a lot of you heard this term before. But what are atoms and what are they made out of in turn? Well, a typical atom would have like a middle section, again a blob in the middle, and I will sort of draw a circle and put letter N in the middle, and then my letter N is going to represent nucleus. So you see I'm using sort of similar terminology here to what was happening in the cell. So that blob in the middle is nucleus. And then around this, blob, that nucleus, you have lots of tiny little objects flying around in circles. And well, I'll draw one, and then maybe I'll draw another one. Let's draw a couple of them. And those little tiny objects, again, I'm wondering if some of you might be able to name what they are, but they're called electrons. So electron, right? So obviously here on my picture, I'll have a couple of those electrons. So electrons, so N is going to represent nucleus. Electron is often represented by this symbol. So it's a little e with a line above it, okay? So this is going to be electron. So nucleus and electron, or electrons, they have charge, okay? So again, maybe some of you will be able to recall from your GCSE, long time ago, for some of you at school, that nucleus is actually positively charged. So it's positively charged. So it's like a plus, okay, and electron is negatively charged, Okay, so it's a minus, and here is the deal, right? However many positive charges you have in the nucleus, let's imagine you have nucleus which has got 2 positive charges in it, then the electrons, the number of electrons would kind of level it, it would be level with the charge of the nucleus. So if nucleus got 2 positive charges, then electron would have 2 negative charges. So you would have 2 electrons flying around, because each electron has got just 1 negative charge. So my atom here, that means I would have 2 positive charges in my nucleus and 2 electrons, so 1 negative charge and the second negative charge, and the kind of the beauty of it all is that they cancel each other out, so then atom overall becomes neutral, okay? Right, so you might say, well, why am I talking about this? We started with our nice human body, which we can all relate to, and we've gone all the way to sort of this scary, pretty much nuclear physics, right? Well, the thing is that in our course of biology, we're going to be using some of the terminology which come from atoms, and you need to be able to kind of relate to these terms and understand at least roughly what it means. Now, let me carry on a little bit longer with atoms. So, depending on how big your nucleus is and how many electrons are flying around that nucleus, this will determine what kind of element you have. Okay, so elements essentially are groups of atoms of particular size. So bigger nucleus would be one particular element, smaller nucleus with fewer electrons would be a different type of element. So all these elements is something you find in the table of elements, and I'm sure you would be able to potentially name a few for me. So in those tables, the elements are represented by letters. So let's have a go at a few. So for example, if I write capital H, what element am I talking about? Okay, so again, as I'm naming them, have a go at pausing the video and naming it and then checking your answer rather than just expecting me to give you the answer straight away. Okay, so capital H, I'm hoping that you'll be able to tell me this is hydrogen. So this is hydrogen. So this element is hydrogen. So hydrogen's got actually the smallest nucleus, so it's just going to have one positive charge and a single electron flying around. So it's really, really tiny atom, right? The smallest you can pretty much get. Now, if I write letter capital C, which element would that be? What's the name of that particular type of atom, of that particular element? So again, I'm hoping that some of you will be able to name carbon. Okay, so we'll just carry on with the same script, right? So I'm writing a letter, you're pausing the video, giving the name and then checking it. So next one, capital O. What is this one? Okay, and I'm hopeful you'll be able to give me the name oxygen. Capital C, little a. What's that one? Okay, so this is calcium. Next one, let's do capital N. What's that one? So this is nitrogen. What about Na? Okay, so capital N and little a. So that's different element to nitrogen, right? Because we've got this little a. So actually, this one is sodium. Right, I know it's a little bit confusing, isn't it? Because you think, well, capital H, that's hydrogen, right? So you're kind of expecting the first letter of a term be the same as the capital letter or the kind of a symbol, but that doesn't always work quite like this. So sodium is actually capital N and little a, and this is because a lot of this symbology derived from Latin and doesn't kind of always translate directly into English. So what about capital K? So that's another one. Don't get caught out. It doesn't start with a K. It starts with a different letter altogether, the name of this element. So this is potassium. So let's try doing Cl. So that should be a little bit more straightforward because there is a bit of a clue actually in those letters. So this is chlorine. What about capital P? Okay, so this is phosphorus. And let's do one more. There's plenty more, obviously, right? F, capital F and little e. This is going to be iron. Okay, iron. So this is what your cast iron pans, for example, are made out of, right? So again, no relation between the term iron and capital F, little e, because in Latin, iron is actually ferrum. So you see that's where the letters originate from. Okay, so I haven't quite finished with atoms yet, I'm afraid, right? So you might be finding it a little bit hard going, but I've got to introduce one more term to you. And you remember what I mentioned earlier, the fact that atoms are neutral, right? Well, you see, the thing is that the nucleus is relatively big, right? We talk about tiny things, but it's relatively big. And then there is quite a long space between nucleus and electrons, and then electrons are flying around the nucleus with a really, really high speed, right? And what sometimes happens is those electrons flying so far away from the nucleus, and they're so fast that they sometimes fly off, right, and leave this nucleus and say, goodbye, don't like you anymore, got fed up sticking with this particular atom, I'm gonna go and, search for my fame and fortune, and that's that.